We'll now continue our discussion of other common functions found in section 3.3. We want to first look at functions of the form a over x to the n. This could just as easily have been written a to the x to the negative n power. Just like we saw in our first segment, these graphs fall into two categories determined by whether or not the exponent is even or odd. Let's look first at an example of the graph of an odd exponent. So I'm going to graph f of x is equal to 1 over x. And this would be, remember, a 1 exponent, so it would be odd. And so the graph will look like that. And what happens as you increase that odd exponent, so 1 over x to the third or 1 over x to the fifth, the curve around the origin sharpens, but the same shape of the graph is maintained. Our second case is where our exponent is even. And so we'll look here at the graph of f of x is equal to 1 over x squared. And so that graph will look something like this. And again, if you increase the exponent to the next even number, making it 1 over x to the fourth or 1 over x to the sixth, then the effect of that is that you sharpen the curve and the graph becomes more steep. All right, so let's look at an example. Sketch the graph of the function f of x is equal to negative 1 over 4x. So keep in mind that this is actually asking you to graph the function f of x is equal to negative 1/4 times 1 over x. And so we know what the graph of 1 over x looks like. The graph of 1 over x has this shape to it. So what is the effect of the negative and of the 1/4? So what does the negative do? We know that the negative causes the graph to be reflected over the x-axis. What effect does the 1/4 have? The 1/4, remember, causes the graph to be compressed vertically. So keeping those two things in mind, along with the basic idea that the graph itself originally looks like this, should allow us to draw the new graph. And so you can see, I'm going to sketch that original graph right back up here so we can talk about it just for a second. Here's your graph of f of x is equal to 1 over x, we said that the negative is going to cause the graph to reflect over the x-axis. So you can see that that's happened. Here's your initial curve. It has flipped up and is now in the second quadrant. Here's an initial curve here, which is flipped down over the x-axis and is now on the bottom. So we definitely see that reflection over the x-axis. The compression is a little bit harder to see visually, but you could definitely see it by using a couple of points. And so you may want to set up, as you're graphing this, a table of values. You might want to try, and I am trying to think of points that might be easy to work with. We might want to try -1/4 and +1. And so we would go to our original function, which was -1 over 4x, and we would plug these values in. So if I plug in a -1/4, now this looks messy, but it will end up being pretty easy to work with. We're going to have -1 over 4 times -1/4. We know that 4 times -1/4, those 4's are going to cancel out, leaving me the -1 on the bottom. So -1 over -1 will be +1, and you can see that that point is plotted right here. So that gives you an idea of where you're at in terms of that side of the graph. And we can do the same thing for the 1. So we can plug the 1 in for the x, which would give us a value of -1/4. That one is here, and again, giving you an idea of what that one looks like on that side. And you can certainly do as many points as you need in order to feel comfortable with your graph. The next thing that we're going to discuss, and we're just going to talk about it real quick, is functions that are of the form a times x to the 1 over n. So this would be the same thing as a function that looks like a to the nth root of x. And so these also fall into two categories depending on whether the exponent is even or odd. And so let me just show you basically what we've got here. If your function is the function x, all right, now this one does meet the criteria for an odd exponent because the exponent is 1. But we know that sometimes the 1's have a little bit different properties. But this would be an exponent of 1, and we know that that is linear. If we increase that exponent and make it a 3, so it would become x to the 1/3, then our graph starts to take on kind of that S curve, but it's a little bit different shape. It looks more like this. And if we increase again on an odd exponent, making it x to the 1/5, we can see that our graph becomes a little more steep, less of a curve. Okay, and starting to bottom out just a little bit, flatten out around the origin. So that's your odd exponent for those cases. For your even exponents, the first one of those would be having a 2. So it would be f of x is equal to x to the 1/2. And so that graph ends up looking like this. If you increase the power, so maybe we make it to the 1/4 instead, then we can see the graph start to flatten out and not be quite as steep. And again, if we're looking at increasing it one more time, so making it to the 1/6 power, then we see that even flatter.